Welcome to lecture number 3, Engineering Material and Mechanics, and the topic is going to cover timber and steel. Timber basically the wood which is suitable or fit for engineering, construction or engineering purpose. Wood basically is the organic matter obtained from tree. You can see the timber log has cut in this picture. You can see, and the types of tree are classified into two groups depending upon the growth pattern, the endogenous tree and exogenous tree. So endogenous tree generally वो tree हैं जो inward, the tree which grow inward in longitudinal fibrous mass are called endogenous tree, and exogenous tree जो कि outward बढ़ रहे हैं, चौड़ाई में बढ़ रहे हैं खास तौर से, the tree which grow in outward across horizontal section of stem are called exogenous tree. These tree are only fit for engineering construction. Exogenous tree are again subdivided in two types: conifer and deciduous. Conifer, also known as evergreen tree, they give softwood and they have pointed leaves. Example: Deodar, pine, Chir, Kail. And again the deciduous tree, these have hardwood. These have broad leaves. Example: टीक, सॉल, शीशम. अगर इंडोजिनियस की बात करें, इसका एग्जांपल हमारे पास में बेस्ट एग्जांपल बैम्बू ट्री है. सो दिस इज द क्रॉस सेक्शन ऑफ अ ट्री. यू कैन सी लाइक दिस इज द आउटर बार्क, you can see, and this portion will be studied as sapwood, and यहाँ पे sap काफ़ी ज़्यादा क्वांटिटी में रहेगा. and this is the hardwood. ये पोर्शन हार्डवुड है जो कि पिथ के नज़दीक होगा. पिथ इज द सेंट्रल पार्ट है, राइट. यहाँ से आपके जो गोल गोल रिंग दिखाई दे रही है, दीज आर द एनुलर रिंग एंड ऑल्सो नॉन एज ग्रोथ रिंग. तो ये रिंग काउंट करके हमें पता लगता है कि पेड़ की एज कितनी हो सकती है, होने के चांसेस. सो दैट्स व्हाई वी कॉल इट एनुलर रिंग, राइट. एंड बार्क की देखें, सो दिस पार्ट इज द इनर बार्क पार्ट एंड द लेयर इज कॉर्क कैम्बियम लेयर. यू कैन सी दिस इज बेसिकली द inner layer of the outer bark, right. And again you can see the same picture in a different view. Medullary rays, you can also see the medullary rays. तो growth circles को जो connect करने वाली लाइन है वो हमारी medullary rays है, right. The fresh timber which is obtained from tree contains about 30 to 40% sap or moisture. This sap is very harmful for the life of timber. Therefore, it is necessary to remove that sap by applying some special methods, and all those methods which are used for removing the sap from timber or collectively termed as seasoning of timber. Now we are going to see what are the different methods for seasoning of timber. So the main types of seasoning are natural seasoning, can be done with air or water. And then after artificial seasoning can be done by kiln, chemical, electric and boiling. They are following methods, right. So natural seasoning, you can see these are the timber logs floating on the water body. So how we can do this? Water seasoning is the process in which timber is immersed in water flow, which helps to remove the sap present in the timber. It will take 2 to 4 weeks of time, and after that timber is allowed to dry. Well seasoned timber is ready to use. पानी जो है अंदर पेनिट्रेट करेगा, और जब एक फ्लो में पानी बह रहा है, so because of the drag force it will pull out the sap of the timber with itself. तो पानी के साथ में सैप बह के बाहर आएगा वॉइड से, और इस तरीके से जो है टिम्बर आपकी टिम्बर से सैप रिमूव होगा, एंड अल्टीमेटली द वाटर कैन ड्राई आउट इमीडिएटली और क्विकली. बाद में आप पेंट वगैरह करके उसको जो है हाईली ड्यूरेबल एंड जो भी उसमें मटेरियल प्रिजर्वेटिव वगैरह यूज करके आप उसको ड्यूरेबल लॉन्ग लास्टिंग बना सकते हैं. नाउ द एयर सीजनिंग प्रोसेस हियर. टिम्बर logs are arranged in layers in a shade. Arrangement is done by maintaining some gap with the ground. So platform is built on ground at 300 mm height from the ground. The logs are arranged in such a way that air is circulated freshly between logs. By the movement of air, the moisture content in timber slowly reduces and seasoning occurs. Even though it is slow process, it will produce well seasoned timber, right. Now we come to the artificial seasoning. It can be done by chemical, or electrical method, kiln seasoning, boiling. So there are several ways. In case of chemical seasoning, timber is stored in suitable salt solution for some time. The salt solution is used has the tendency to absorb water from the timber. Okay, so this is a chemical seasoning. Now electrical seasoning. In this method, electrical seasoning timber is subjected to high frequency alternating currents. The resistance of the timber against electricity is measured at every interval of टाइम, और उससे आपको पता लगेगा कि टिम्बर आपकी कितनी तेज, कितनी ड्राई हो चुकी. किल सीजनिंग. इन दिस मेथड टिम्बर इज सब्जेक्टेड टू हॉट एयर इन एयर टाइट चैम्बर. द हॉट एयर सर्कुलेट्स इन बिटवीन द टिम्बर लॉक्स एंड रिड्यूसेस द मॉइस्चर कंटेंट. बॉइलिंग के केस में हम पानी में इसको 3 से 4 घंटे तक बॉईल कर सकते हैं टिम्बर को. आफ्टर बॉइलिंग टिम्बर इज अलाउड टू ड्राइंग. फॉर लार्ज क्वांटिटी ऑफ टिम्बर बॉइलिंग इज डिफिकल्ट, सो समटाइम्स हॉट स्टीम इज passed through timber locks in enclosed room. It also gives good result. Now advantages of seasoned timber. It has reduced weight. It is strong and durable. It has resistance to decay or rot. It takes high polish. It is easier to work. Its life is more. Uses of timber in construction of beams, rafter, bridges, piles, poles, railway sleepers, for packaging of material, for manufacturing of agricultural implements, for making toys. So defects in timber. A defect is an irregularity or abnormality occurring in or on wood, okay, which is responsible for strength reduction and decay, lowering the durability, lowering of utility, poor appearance. So basically defect होने के कारण strength reduce होगी and durability कम होगी, utility भी कम हो जाएगी and poor appearance तो रहेगा ही रहेगा. Most common defects in timber are as follow: natural defects and artificial defects. तो defects को हम लोग दो तरीके से देख सकते हैं, natural, artificial. Okay, natural defects की अगर बात करें, so different shape के कट you can see here. Okay, and उस कट के अकॉर्डिंग, जिस टाइप का कट है उसके अकॉर्डिंग उसका नाम, हार्ट शेक, स्टार शेक, फ्रॉस्ट शेक, कप शेक. You can see the shape of this cut is like cup. So ring shape, so like the ring type. So these are the defects. Okay, रिंग का बेसिकली ये सरफेस पे एक अलग तरीके की abnormality आ जाती है. So these are also the defect. And knot may be there on the like this is the knot in the timber. A big log is there, and if knot is there, it would be difficult to have the same kind of flow of deformation. Okay, because of this knot, the deformation will restrict and stress concentration may occur at this point where knot is there. So knot is not good for the beam mainly. And then dead wood is there. So now artificial defects की बात करें, warp, bob, cupping, twisting and checks. Now I come to the steel. What is the steel? Steels are essentially alloy of iron and carbon, but they always contains other elements either as impurities or alloying elements. Steel is man-made metal containing 95% or more iron and 1 to 2% carbon. Smaller amounts around 1.6% of manganese and nickel to improve the certain property. तो स्टील में जो मेनली कंपोजिशन स्टील का है वो आपका आयरन एंड कार्बन रहेगा, आयरन ओर रहेगा एंड कार्बन रहेगा. कार्बन काफ़ी इंपॉर्टेंट है. कार्बन की हल्की सी और छोटी कम क्वांटिटी, इवन स्मॉल क्वांटिटी ऑफ कार्बन कैन चेंज drastic properties of steel. And further like we can see, addition of carbon improves the strength and hardness but reduces ductility and toughness. तो कार्बन की अगर क्वांटिटी हम इंक्रीज करें तो इनिशियल स्ट्रेंथ तो बढ़ेगी मटेरियल की, लेकिन डक्टिलिटी उसकी खत्म हो रही है कार्बन के कारण. जैसे जो अगर माइल्ड स्टील का हम लोग कर बनाते हैं, सो इट इज समथिंग लाइक दिस. और डक्टिलिटी मतलब फेल जो है काफ़ी इलोंगेशन के बाद होगा, बट इन केस ऑफ हाई कार्बन स्टील इट विल देयर विल बी सडन फेलियर आफ्टर much smaller elongation. Now different types of steel are there: carbon steel, alloy steel and stainless steel, and then tooling. So okay, so carbon steel is the steel where the main alloying constituent is carbon, and it can be categorized low carbon, medium carbon and high carbon steel. Low carbon up to 0.25%, medium carbon up to 0.25 to 0.45%, and high carbon steel 0.45 to 1.5% percentage of carbon, right? And then after stainless steel की अगर बात करें, it is alloy, steel alloy with a minimum of 10.5% and up to 30% chromium content by mass. And then alloy steel is a steel alloy with a variety of elements in amount of between 1 to 50% by weight to improve its mechanical properties like aluminium, copper, manganese, silicon and vanadium. So these are the alloy. Now tool steel is also there, refers to multiple carbon and alloy steels that are particularly well suited to be made into tools. So better for hardness, abrasion resistance, okay, resistance to the deformation at elevated temperature. तो टूल बनाने के खास तौर से काम में आते हैं, जहाँ पे हम लोग इसकी हार्डनेस और एब्रेशन रेसिस्टेंस काफी इंप्रूव कर देते हैं. And now we can see the stress strain curve. Stress strain curve I have already discussed in detailed way in different video. You can also see the stress strain curve here. Like in this region the Hooke's law is valid because stress is directly proportional to strain. After this there will be elastic limit, and then like you can consider it very close to this, and then after yield point is here. After yield the region will be plastic, completely plastic, okay, and you can see the strain hardening region and naking region, and somewhere the yield plateau is there, but in this curve it is not considered. There may be a little variation in the curves, not every time all the curves are same, depending upon the requirement. And okay, so this is the fracture and this part is naking. यहाँ पे strain hardening है. strain hardening में yield आने के बाद में आपका जो है strength again material is taking more strength, okay, as well as stresses are strain is also there. Strain is continue to happen, and this is the ultimate point. This is the ultimate point. इसको हम लोग सिग्मा u बोलेंगे, right? And this is ultimate. इसको like सिग्मा u यहाँ पे आएगा ultimate strength, and सिग्मा y रहेगा हमारा yield stress पे, and ultimate stress या ultimate strength बोलेंगे. And then after there is a fall or downfall, and finally naking. यहाँ पे naking होगा जब जो आपका बार है वो एकदम नेक करके टूट जाएगा, right? कुछ इस तरीके से नेकिंग फॉर्मेशन होगा स्टील रॉड में, और यहाँ पे जो है सैंपल ब्रेक होगा, एंड दिस इज द फ्रैक्चर एंड नेकिंग रहेगा. एंड दिस पोर्शन, इस पोर्शन में जो है कंप्लीटली कुछ इस तरीके का डायग्राम आ जाएगा. एंड दिस इज द ट्रू कर्व जहाँ पे आप एक्चुअल एरिया ले रहे हो, एंड दिस इज द इंजीनियरिंग कर्व. एंड यू कैन सी द Hooke's law is valid, and sigma is stress, and strain is change in length to the original length, and is the modulus of elasticity in PA. So these things has been discussed here. These are the different curves. Now in this curve you can see this is the yield plateau, PLATUE plateau, and yield plateau is there. Then strain hardening region is there, naking region is there, and this yield stress is proportional limit is there, ultimate stress is there. So everything is there. You can see the different shape of the shaft observed, and this failure you can remember the cup and cone failure, okay, cup and cone type failure, CONE, cup and cone type failure. So these are some stress strain curve for ductile material, जहाँ पे अल्टीमेटली यील्ड क्लियर यील्ड नहीं मिलेगा डक्टाइल में. सो ओके, यील्ड स्ट्रेसेस कुछ इस तरीके के रहते हैं. सो इलास्टिक रीजन, स्ट्रेन हार्डनिंग रीजन, नेकिंग वेरियस रीजन हैज बीन शोन इन डक्टाइल. एंड ब्रिटल की बात करें तो इलोंगेशन काफी कम है, बट अल्टीमेट स्ट्रेंथ में भी हाई. सो नाउ द मेरिट्स एंड डिमेरिट्स ऑफ स्टील: हाई स्ट्रेंथ टू लो वेट रेशियो, हाई स्ट्रेंथ टू लो वेट रेशियो रहेगा. गुड फॉर लॉन्गर स्पान ब्रिजेस, टॉल बिल्डिंग्स, लाइट वेट स्ट्रक्चर है कंपेयर टू कॉन्क्रीट. Lightweight compared to concrete, can be held and transported and prefabricated. Right? Uniformity, its properties due to manufacturing and controlled environment. Like concrete के केस में थोड़ा uniformity, homogeneity maintain करना difficult है, but in case of steel it can be done easily. It's a ductile material and hence does not fail suddenly and gives visible evidence of failure by large deflection. So ये बड़ा advantage है, right? डक्टाइल है, एकदम से फेल नहीं होगा, और आपको कहीं ना कहीं इंडिकेशन रहेगा, सिग्नल्स मिलेंगे कि कहाँ से स्टील फेल हो सकता है. मॉडिफिकेशन ऑफ स्ट्रक्चरल अलाइनमेंट कैन बी डन इजीली, फास्ट कंस्ट्रक्शन पेस एज कम्पेयर टू रीइंफोर्स सीमेंट कंक्रीट, क्योंकि सीमेंट कंक्रीट को हार्ड होने में इट टेक्स टाइम. हार्डनिंग फॉर हार्डनिंग steel has the highest scrap value, that is the big advantage. Now demerits, possibility of corrosion is too high. corrosion की possibility रहती है, लेकिन हम लोग corrosion resistant बनाते हैं by many preservatives and other things, red oxide, other things. Like overall construction cost increases multifold, काफी costly है compared to reinforced cement concrete prepared, required high maintenance cost, maintenance needs fireproof treatment, looking into possibility of fire.